Okay, folks, so we're going to talk about our heat capacity of a Bolt lab here. We did this lab in class, and basically what happened was, you can kind of read the instructions, but we had a bolt that we got the mass of, and then we boiled that bolt in water for 5 minutes. So we wanted to make sure that the bolt's temperature was at 100 degrees, because that's what boiling water's temperature is, 100 degrees. And by putting it in there for 5 whole minutes, we know that the bolt has reached that temperature. So what we did was, we had 60 milliliters of water in a couple of styrofoam cups. We got the temperature of that water before we tossed the bolts in. And then we put the bolts in, we swish it around, the temperatures kind of mix, and we get this final temperature for water. And if we have those two pieces of information, along with the mass of the bolt itself, and the mass of the water in those cups, so what we did was we had the mass of the cups while they were empty, and then we filled them up with 60 milliliters of water. We got that number as well. And we used that to get the mass of our water, which I'll show you a little bit more specifically here in a moment. So what we're trying to do in this lab is we're ultimately trying to find the specific heat capacity of the bolt, or that is the C in the the Q equals mc delta T equation. So we're going to go through how to do this calculation. It's the first time we're doing a Q to Q, which you'll see what that means here in a minute. So the numbers that I'm going to use are when someone actually did this lab. Okay, so this is a student from last year. Here's their data. So first things first, I'm going to go ahead and calculate the mass of my water. Since it was supposed to be 60 milliliters, I know the mass should be close to 60 grams because the density of water is 1 gram per milliliter, but I want to get the exact mass. So I find the difference between these two. So the cups by themselves are 9.01 grams. When I had some water in those cups, they went up to 67.19. So the difference between those two will tell me how much water is actually in there. And for me, that was 58.18 grams, which makes sense. That's close to 60 grams, which is about what 60 milliliters should weigh. Now I'm going to go ahead and take a look at my temperature numbers. So my final temperature was 28.7. And so that's where the bolt and the water met. So the bolt started way up here, okay, and it came down to the 28.7. Oh, that's a really sketchy arrow there. My smartboard is a little off today. And the water was a little bit cooler temperature, and it went up to the 28.7. So the initial temperature of the water, that was pretty straightforward, is our 23.6 from up here. But what was the initial temperature of the bolt? Well, the bolt was in boiling water for 5 minutes. Water boils at 100 degrees. So that bolt was at 100 degrees right before we put it into the cup with the cold water. And so the bolt was actually all the way up at 100, and it came down to 28.7, whereas the water was down at 23.6 and went up to that mixed temperature of 28.7. So the delta T of our metal, that would be the 100 minus the 28.7. So we're taking a look at these two guys right here. And that will give us 71.3. But the delta T of the water, notice I'm not just saying delta T, I'm being specific. The delta T of the water is the difference between the final temp and the initial temp of the water. That's going to be 5.1. Okay, so here's the big idea from today's lab. The Q of the water is equal to the Q of the bolt. The Q of the water is equal to the Q of the bolt. In other words, the temperature of the water, it went up a little bit. And the only way that that happens is if energy is entering that water. Now, the only source for energy to enter that water, in this case, was the super hot bolt we just dropped in there. So the water gains a certain amount of heat energy, a certain amount of Q, but the bolt is the source of that energy. So the bolt loses a certain number of Q, and the amount of Q that the bolt loses should be identical to the amount of Q that the water gains. Remember the law of conservation of energy. Energy that is gained by something must have been lost by something else. So energy gained by the water came directly from that bolt. So their two Qs are going to be the same. And another way to write Q would be to write mc delta T, because remember Q equals mc delta T. So on the left here, I have the mc delta T of water, because that should be the Q of water. On the right, where I have the Q of the bolt, I have the mc delta T of the bolt. So I have two different masses, two different C's, two different delta T's, because they were talking about two different things. So my mass of my tap water that was this guy up here, my 58.18 grams. That's what I'm putting here. I do know the C of water because it's liquid water. It's always going to be 4.18. And the delta T of that water, well, that's just that small little 5.1 we just calculated. Now, the mass of the bolt's different. My mass of my bolt was, I moved him here. I meant to highlight him, was 38.49. So that's why I'm plopping that here. The C of my bolt, that is what we're trying to find during this lab. That's the one thing I don't know. So there's our variable that we're introducing here. And delta T of my bolt I just calculated. That was this higher number, the 71.3. So that's what goes here. And there we go. So now we have one variable, and we can solve. So I'm going to simplify that on the left. 58.18 times 4.18 times 5.1 is 1,240.28. 38.49 times 71.3, that is 2,744.34. And it's still multiplied by our C, which is what we're looking for. Now to get C by itself, I could divide both sides by 2,744.34, 2,744.34. These will cancel out here. And so I'll be left with just the C all by itself. And that comes out to be 0.45 joules per grams degrees Celsius. So this Q to Q calculation where we solve for C, this is a new type of problem that I want you guys to be able to do. I'm expecting you guys to be able to do this on your test, which is next Thursday and next Friday. So we have a week from today, October 14th. So you guys got to be able to do these Q to Q calculations. Next week, we're going to start with some extra practice on Q to Q to make sure you guys are ready and you shake off the rust from the long weekend. Okay, that's it for today, folks. Make sure you really understand this. Please email me or let me know if you have any questions, and I'll see you next time.